requirement for this is that the vectors have the same size. For instance, if you have, let's call this A, and if you have this, so both of these vectors are of size 1, 5. That is, they have 5 elements and they are row vectors. And then you can do this or this, and you can also do element-wise product. However, in order to do an element-wise product, what you need is that you need an operator with a full stop before it. So if you do this, you do an element-wise product. Note that this is different from the multiplication symbol, which is just an asterisk. Instead, you have this dot before that. So you have element-wise product, and you can also do element-wise multiplication. This holds for matrices as well. That is, if you have M, let's print that out. You, for the sake of convenience, I'll just assume that the other matrix that we are adding with or multiplying with is also M. You can do that, and here you would expect a 0, and it's a 0. You can also do this, or you would expect all ones here, which is all ones. But the more important question is, whenever you're working with MATLAB, you would want to do matrix multiplication. That is not the element-wise multiplication, but the actual matrix product. In which case, you will not use the dot. Instead, you will just use an asterisk, and it'll be a matrix multiplication. In order for you to do matrix multiplication, if you're multiplying two matrices of size or two matrices A and B, then make sure that A is of size M cross some R and B is of size R cross some N. It's only then that this will work. And if you do not do that, then it'll throw an error and say that you need to make sure that the dimensions agree. Do we have any questions on this? Yeah, good.
So when you put dot and when you didn't put dot, what is the difference in the product? If you can explain that. Milind, your voice is not coming.
I think he has got disconnected or what?
So anyone having access to Milind can call him. His voice is not coming.
Hello, what happened, sir? Milind is
got
Milind, I think he has got disconnected.
I'll just call him, sir. I'll just call him 1 minute.
Yeah, I'm back. So there was a power cut at my place. Sorry for that. So can you guys hear me?
Yes, Milind. Yes, we can hear you.
Yeah. Sorry for that. So I'm presenting my screen again. So I'm assuming you can also see my screen.
Milind, my question was that when you put dot and you didn't put dot, what is the difference in the product? I mean, so if you can explain that. I think he again got disconnected.
Yes. The moment you ask Ashok, you question, he gets disconnected.
So I will not ask now onwards.
What a coincidence.
Sir, meanwhile, I can explain what is the difference.
Yeah, please, sir.
So what happens is, I will just open my text editor and explain. So what happens is when you put A dot star B, elements of both these things get multiplied. Okay, so for example, you can see my screen
not now, sir. Not now.
Okay.
Your screen is not up.
I'm just going to share my screen.
No, we are not able to see your screens.
It's not allowing me to share my screen for some reason. Milind said he'll join in 2 minutes if there's some power issue. Meanwhile, I'll explain this part. Sir.
I'm back. So
back?
shall I continue the class, sir?
Yeah. I'll stop.
Yeah. Sure. Sorry, there seem to be some repeated power outages at my place. Yeah, so sorry for that. So yes, there was a question. Should I answer it, or
please go ahead,
already answered?
No, you had to answer.
Yes, please tell me what the question is.
The question was that when you put the dot and then multiplied, and when you put, you didn't put the dot and then multiplied, what was the difference?
Okay. So when you put the dot and you multiply, it's an element-wise multiplication. For instance, look at this. M is 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you do M dot star M, you get 1 into 1, which is 1, 4 into 4, which is 16, 7 into 7, which is 49, and so on and so forth. However, if you do matrix multiplication, then what you get is, let me also display M for you. So what you instead get is the first element here will be the first row of M into the first column of M, which is 147 into 123, which is 1 into 1, which is 1, plus 8, which is 9, plus 21, which will give you 30. So the difference is when you do dot star, you're doing element-wise multiplication. So if you have two matrices A and B, you're multiplying Aij with Bij. However, if you're doing star, you're doing matrix multiplication. That is every element. So every element of the resulting matrix Cij is given as summation over k aik into bkj. Does this answer your question?
Yeah.
Great. Right. So reshape and repmat. So reshape is a function that just lets you reshape the matrix. So for instance, if you have M and you want to say convert it to a column vector, what you would do is you would say reshape M and you want one column. So you would do this. Or say you had a vector of say 9 elements and you want to reshape it into a 3x3 matrix. You would say M is equal to reshape M, 3, 3, and it gets reshaped into a 3x3 matrix. And you can use this and play around, and I can't think of an immediate example where you would use this in your assignment, but maybe further down the line when you are doing channel estimation and you want to convert that into a vector which you want to then use to solve some linear equations, these kind of things will come in handy. Another thing is repmat. So what repmat does is, given a matrix, it uses that as a block to build bigger matrices. So for instance, we have this matrix M. Now, if I say N is repmat M2, 1, what this means is repeat this matrix twice vertically and once horizontally. So what you get is this. So this is
one suggestion, can you increase the size of your command window, please?
Yeah, sure. Yeah. So if you can see repmat M2, 1, M is this matrix. And repmat 2, 1 is just repeat this twice along the rows, which is what has happened, and repeat this once along the columns. So it's been repeated exactly once. So say instead if I were to do N is equal to repmat M, 1, 2, then you would get this matrix repeated twice along the columns and once along the rows. So there's M in the rows once and twice along the columns. So where would you use this? Well, there is no immediate application in your assignment, so you can rest easy about that. However, further down the line, say you're doing LDPC encoding or something like that, you might have to use a single matrix to generate multiple matrices. And at times like this can come in handy. Or say you have a vector and you want to multiply it with a number of scalars, and you could just make a matrix out of it and do column multiplication. There are several applications, and it's all context dependent. So these are just useful functions to know. So do we have any questions about this?
Hello. How did you first create the 1 to 9 matrix?
So there are several ways of doing this. You can actually either just type out 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9, or you can do 1:9, which will give you a row vector from 1 to 9. And then you can say M is equal to reshape M. I can either say 3, 3. I mean, I do have to say 3, 3 in this case, and we'll reshape that into a 3 × 3 matrix. Is that okay?
No, before this reshape, you created the 1 to 9 matrix, right? How did you do it?
You mean this?
No, before the reshape.
Yeah, you mean this, right?
No.
No, he's asking how did you create the 3 × 3 matrix of 1 to 9? I think he typed it.
Okay.
This one, the original M.
No, like
you mean
10
this?
minutes ago.
Yeah, this.
Yeah, this is exactly what I did. I just made it 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I did reshape.
Otherwise, you can also type it out.
Yes, exactly. You can also type it out.
Okay.
There's several ways of doing it. Does that answer your question?
So maybe you just want to type it out and show it.
Yeah, sure. So you could what you could instead do is 1, 4, 7, 2, 5, 8, 3, 6, 9. So you can type it out like this and then result in the same matrix.
Okay.
Okay, cool. So then we'll move on to random numbers. There's a lot of mathematics behind how to generate random numbers, and we will not go into that today. I mean, this is stuff you can look up if you want to, but primarily we're concerned with generating uniformly distributed. Yeah.
One small thing, can you also tell inverse INV?
Sure.
Inverse
so I'm assuming this. So inverse basically finds a matrix inverse. Now, what is a matrix inverse? Say you have a matrix M, then a matrix inverse is a matrix N such that M multiplied with N will give you the identity matrix. Okay. So for that, there are several conditions for that. One, M must be square. If M is not square, I mean, there are other ways of finding an inverse, but the inverse as such is a word used for square matrices. M must be invertible. That is, it must have something known as full rank. That's something you can look up. But like this matrix M is most likely invertible. So you can find this inverse using the inverse function. So this is
not invertible.
Not invertible. Great. So if it is not invertible, this is what happens, and you get a warning saying this is singular. So don't do such things.
You just create a matrix and invert it.
Okay, sir. So let's assume M is rand n of 3. So we'll come to this in a few moments. So this is a Gaussian matrix in which the elements, a 3 × 3 matrix in which the elements are drawn from a Gaussian distribution. So we have this matrix. Let's try inverting this. So we do that. So it's invertible, good for us. So now how do we check that N is indeed the inverse? We have to do a matrix multiplication. Remember, this is not the dot star element-wise multiplication. This is the matrix multiplication.
So Milind, in the first case, why that was not invertible? Because I mean, and here we are able to invert.
Right. So this is not what is known as a full rank matrix. In fact, If you were to reduce
I think it's a full rank matrix, but find the determinant of M. I think it's close to 0. It's a full rank. No,
it's not even close to 0. Oh, I've changed M. Sorry.
So exactly what it is doing when it is calculating invert kind of.
I mean, maybe you should show them Wikipedia or something once.
So determinant is 0, sir.
No, that's fine. So what do you mean by invert here then? I mean, suppose mathematically I have to calculate invert of 1 or 4.
Yeah.
How do I do that?
So y is equal to ax is there, sir. So you have a set of equations. Y is equal to ax.
Okay, sir.
And you want to find x. You do x is equal to a inverse y, na?
Okay.
So that is the inverse that we are talking about.
Okay.
The matrix inverse.
Okay.
Okay. I will share some material with you on that, sir, on the matrix inverse. I mean, that will clarify this. So essentially, it's mainly used to solve linear equations. So when you have a set of equations, y is equal to ax, and you want to invert and find x.
So please forgive me for such silly question, because that may be
no,
very normal for you, but it's.
I will send some material on that, sir. I'll put it on classroom.
Okay, sir. Okay, right.
Okay. So you have to, so essentially, if you have y is equal to, for example, 3x, you say x equal to y by 3. Okay. But when you have a matrix where y is equal to n cross 1 and a is equal to n cross m and x equal to m cross 1, let's assume n and m are same also. So then how do you find the solution of y is equal to ax? So then you do an inverse. Okay. I will put some material on that on the classroom. Okay, Milind, you can go ahead, please.
Yeah. So once you go through the material sir puts up, you'll understand that there are certain conditions that are required to be satisfied before you can invert a matrix. And in this case, those conditions aren't satisfied. One of the conditions is the determinant of the matrix must not be 0. It is 0 here, so you can't invert it. So that's another thing you can keep in mind. Well, you will not be using this for the first assignment, but in future assignments, you will most likely come across the inverse function, and you will need to use it. So be careful when using it.
So if you can also explain determinant, what is determinant?
I think when sir puts up the material, all these things are interrelated.
Okay, fine,
so what matrices are, what the determinant is, and how you get an inverse. So if I say determinant, then I'll have to explain an adjoint. So let's not go there. Please go through the material that sir puts up, and in case you have any questions, just feel free to reach out to us and we'll help you out. Is that okay?
Yes.
Great. So coming back to random numbers, the things we want to look at here are how do you generate numbers from a uniform distribution. Now, what is a uniform distribution? Well, a uniform distribution is something that looks conveniently like this. That is, if how do I explain this? So if you're choosing a number from a set of numbers, then all the numbers are equally likely. That is, the probability of getting any one of those numbers when you select one at random is the same. So that is your uniform distribution, and if you visualize it, it would look something like this. That is, it would be flat. I mean, just ignore the y-axis for now. It would be flat, and it would depend on how many elements you have. Now, so you can generate uniformly distributed random numbers using the rand function in MATLAB. So if you just type rand, you'll get a single uniformly distributed random number between 0 and 1. So where can you use this? Well, an immediate hello. Any?
We can hear you.
Okay,
I can hear you. Yeah.
Yeah, great. Right. So you will use this when, say, you want to generate a bit. So an integral part of your assignment is, it says, assume that all bits and all constellation symbols are equally likely. That means all the bits that you generate must be equally likely. So what you want is, there are only 2 bits, 0 and 1. So you want the probability of generating each bit to be 0.5. So how will you do that? You will say, every time I want to generate a bit, generate a random number between 0 and 1. And if the value of that random number is less than 0.5, then set that bit to 0, otherwise set it to 1. So this will give you a uniform distribution on 0 and 1. Now you don't have to take my word for it. When we get to for loops in the same tutorial, I'll show you that this is in fact true. But this is one application. Of course, the rand function can also be
I think Milind have some issue with the internet again.
I think he lost the connection again.
So let's wait for him. Maybe the power cut again. Yeah.
Yeah, I think he'll just join in a minute.
So in the meantime, when he just wrote rand, it gave answer as 0.6276. Why? I mean,
yes.
So
essentially, rand means it will generate a uniform random number between 0 to 1.
Achha, so
okay.
So the command itself works for 0 to 1, right?
Only 0 to 1. There are other ways you can modify this to for other values.
Okay.
But rand by itself gives 0 to 1.
0 to 1. So so binary distribution would be possible by the rand itself, right?
By binary won't be possible. So what he does is he will now use that to convert. So essentially, if you have something from 0 to 1,
right,
immediate uniformly distributed from 0 to 1, you can see that the probability that the number is whatever number you get is less than 0.5 is 0.5. Okay. And greater than 0.5 is 0.5.
So that means means if I use this command for say 100 times and then I compare, then I'll get 50% which will be less than, less than 0.5 and 50% more than 0.5. Is that the case? Okay.
Yes, sir. Exactly.
Right. And will it be true for smaller samples? Suppose I only run this command twice.
No, it will not be. So that is law of large numbers, sir. But what you will do anyway in our simulations, what we do is we generally generate them over 10,000 iterations or so, no?
Okay, so very large. So that will be true in a large set of such numbers.
In a large set, but saying that it is actually a clean random variable between 0 to 1. Okay. In this, I think Milind, you got disconnected. So you might have to talk about histogram and other things once. Milind.
Yes. Sorry.
So this one question: how can we generate a random sequence or symbol where symbol means more than one number of bits? Sir, he will tell you. I mean, we can use rand to generate that one. He will tell you how to do that.
So can you please repeat your question, sir?
Is there in the chat box?
Okay, great. How can we generate random sequence of symbols where symbol means more than one number of bit? Okay, yeah, sure. We'll get to that. I mean, that is shown below. I'll get there. And if I don't, feel free to ask again, and I'll let you know. So here, at this point, I'm just trying to convince you that if I were to repeat this, say, 10 power 5 or 10 power 6 times, we will still get a uniform random distribution. So what I'm doing is I'm generating around 1 lakh. That is 10 power 5 uniformly distributed random numbers. And now I'm plotting a histogram of that. I will tell you what a histogram is. Just give me a second. So histogram is, on the x-axis, you will plot a range of values. That is, we call them bins. That is, say 0 to 1, 1 to 2, 2 to 3, 3 to 4. In this case, it's 0 to 0.01 or 0.01 to 0.02 and things like that. And on the y-axis, we will plot how many values lie in that range. That is the frequency. And this represents what the distribution is. So here you can see that it's more or less flat. If I were to increase this A to say, if I were to add one more 0, or let's say 2 more, and then I were to plot the histogram, then it's more or less flat. So this is exactly what it is. So you can be sure that it's a uniform distribution. And this is, there's another way of generating these bits. You can use the rand_int function. The rand_int function, it's the rand_i, which is random integers. It will only generate integers which are uniformly distributed. There are several definitions for this function, so please check the documentation. And here, this is the line we're going to use to generate bits, and it will produce the same result. So are there any questions on this?
One thing is, Milind, can you just tell them how to generate multiple bits, zeros and ones?
Right. Okay. Sure.
To show a specific example.
Right. So this is something I have down the line. I wanted to introduce the for loop later. So how will you generate multiple zeros and ones, right? So look at this piece of code. Let me just reduce the command window a little bit. Right. So we have an empty array of bits, and we want to generate, say, 10 power 6 bits. That is 1 million bits. So we will iterate over the number of bits. That is, we will say 10 power 6 times do the following. Generate a random number between 0 and 1, which is uniformly distributed. And if that random number is less than 0.5, set bits, the ith bit to 0. Otherwise, set the ith bit to 1. And just as I've done before, if we plot a histogram of bits, you get a uniform distribution. So let me run that for you. And so if I were to do size of bits, you'll notice that it's a 1 cross 1 million size vector. Does that answer your question? So is there anything else I should elaborate here?
No, I mean, do you want to tell them how to generate a vector of bits, random bits?
Oh, I just did that. Okay, so if you want to generate a vector of, say, uniformly distributed random numbers, what you will do is you will say, instead of, so let's call this vector bits is equal to rand of, you will specify a size. That is, instead of just saying rand, you will say you want to generate 10 uniformly distributed random numbers, which is a column vector. So you'll say 10, 1. And that's exactly what you get. You get a vector of random numbers. So that's all there is to it. It's fairly simple, and there are several ways you can manipulate this. You can also generate a matrix and etc. and so forth. So for this, I recommend that you look at the documentation. So I'll move on to Gaussian random numbers. Now this is very crucial even for your assignment, and this is in general something that you need to know. So we do in MATLAB, we do this using the randn function, and that will generate a random number that is drawn from the standard normal distribution. That is a normal distribution in which the mean is 0 and the variance is 1. And in this case, I have generated 10 power 6 values using the vector form of the function, and I've plotted a histogram, and you can see that the distribution is indeed Gaussian. And I've printed out the mean, which is very close to 0, and variance, which is very close to 1 for you. Well, all this is fine and dandy, but oftentimes what you need to do is you need to shift the distribution. Say you're doing your assignment, and you want to vary the SNR value. The way you will vary your SNR value is by varying the noise power. And the noise power is equivalent to the variance. So how do you vary the variance? Or say you even want to shift the mean. How do you do that? Well, MATLAB does not have an inbuilt function for that, to the best of my knowledge. What you will instead do is you will use the following equation.
Show us creating that Gaussian distribution practically onto the command line, if it's possible for you.
Yeah, sure, no issues. So let's say we want to generate 10 power 6 samples. So that'll be 1E6. And I will say vector Gaussian is equal to rand n of n, 1. And I'll not display this for you. And if I do a histogram of vector G, this is exactly what you get. You see that the mean is 0. And well, you would have to compute, I'll compute the variance for you here. Vector G. And that's very close to 1. If I were to increase the number of values from 1E6 to say 1E7 or 1E8, this would get even closer to 1. Does that help?
Variance means, I mean, the highest value or lowest value from 0, or?
No. Variance is defined.
Variance means it's expected value of x square, sir. So instead of variance, he could have multiplied each value by itself. Essentially, the power in the signal. So it's not the maximum or the minimum value, but it's roughly indicates that, sir. Roughly indicates how much is the spread. So for
Spread,
example,
basically, Professor, this is a spread rather we should say.
yeah,
Yes,
spread.
exactly.
Because the power is directly proportional to the spread, and sigma square we use in the noise power something.
Yeah, sigma square is spread. Sigma square is the power. Sigma is the spread. So if you
Spread,
take the
right.
variance, yeah, it's one now. One, I mean, there's samples outside one also, but so essentially what you can think about is it's equal to expectation of x square. So what?
Expectation of x square. Yes, yes.
Yeah,
Right.
expectation of x square.
Thank you.
In fact, I think you can see this if I were to do mean of
Variance samples to sample.
Vector G over 2. It's the same. This works because this is a zero mean distribution. If it were not, you would have to subtract the mean and then take a square. Now, regarding whether it's the spread or not, this is easy to see. So greater the variance, greater will be the spread, and the broader will be the distribution. So what you're doing here is essentially saying, so there is a property of random variables which says that if x is a normally distributed random variable with mean 1, with variance 1, then sigma x will be normally distributed with variance sigma square. And similarly, you can add or subtract the mean, and the mean of the distribution will shift. Again, I will share some materials on this with you on the classroom. So if you're a bit rusty theoretically, you can look at that and refresh your knowledge of random variables. But essentially, if you want to shift away the distribution to a different mean, you would add the mean and you would multiply by the standard deviation. So that's exactly what we've done here. Now we want a distribution with a mean of 2 and a variance of 3. So what we will do is we will multiply by square root of 3, that is the standard deviation, and we will add the mean. So if you look at this distribution, I will also show you this in command line, but just take a look at this for now. So we have a mean of 2, and if we compute the variance, it's very close to 3. Now I did say I'll show this in command line, so let's take a look. So this is, I want to generate 1 EE6, that is a million values. Let's say my vector is rand n of n comma 1. So we have a vector of standard normal values. Now we want to shift this. We want to change the variance to 3. So we will do v is equal to square root of 3 into v. And now we want to shift the mean to 2. So we'll do v is equal to v plus 2. And now we'll plot a histogram of v. You will see that the distribution is centered at 2. Well, what about the variance? We will compute the variance of v. And it's very close to 3. If I were to increase the number of values here, it would be even closer to 3 than 3.0014. So do we have any questions? Great. So I'm assuming, yeah, okay, I'm still connected to the call. So there are just a few more things left. I'll walk you.
Excuse me.
Yeah.
That rand function after running is giving some value between 0 to 1. Na?
Yes.
What exactly MATLAB doing while producing any value?
So I can answer that. So MATLAB, actually the random number generation is a very, very complicated thing. So it does a lot of, there are some shift register based random generation techniques and other things. It's a complicated topic by itself on how the random number is generated. What it does, it can actually it has a seed value, it takes the time of day, it takes the seconds and the milliseconds, and then based on that it runs something called an LFSR. Okay, and based on that it generates random bits, and from the bits it calculates the random value. Okay, I think we can, I mean, if you are interested in that, I can send you some material on 1-by-1 basis. It's a little bit out of, I mean, it will take us way outside this, what we are doing. Chitrana, is that fine? So when you say rand, all we have to understand as of now is it gives us a uniform random variable between 0 and 1. How it does that, it's a big topic by itself. Okay, I mean, if you are interested, I can give you some material and some indicators on how it does that.
Okay, sir. Okay.
Go ahead, Milind. Oh, Milind left. Huh? He's one of us speaks. He's sleeping. See, one thing is just a basic introduction to MATLAB. I think once you start writing up code, will take some time. It's okay. All of us will take some time. We'll write it slowly. I mean, whenever there's any problem, we can do. You will start understanding all these things better. It's actually pretty easy, much more easier than C language or anything.
Yes, sir. When you start doing, then only will come to know, then will become slowly.
Exactly. It will take some time. Let's not worry about it so much.
Yes.
I mean, a couple of assignments, once you do that, it will take some time for you to become efficient. I mean, it's okay. Milind, are you back?
Yes, sir. Yes, I am
Okay,
back.
please.
So we have 20 minutes in the class, and I'd like to wrap this tutorial up. So I'll be going a wee bit faster. So I hope that's okay. And of course, I will stop and answer any questions that you may have. So next we'll move on to conditional statements. These are the if statements and if else and if else if statements, without which you will not be able to do anything sophisticated. So before we move on to the if statements, we need to understand a few things. The first is relational operators. That is, how do you check if two variables are equal or greater or not equal or greater than or equal to, and those kind of things. So we will check that with a couple of variables, and I'll show you what all the operators are. So if, okay, is anybody saying something?
Nothing. Go ahead. Go ahead.
Cool. So I'll set one of the variables equal to 3 and one of the variables equal to 4. Now clearly these are not equal. So how do you check equality? You use a double equal to symbol. Maybe I will just increase the size of this a little bit so that it will be easier for you folks. So you use a double equal to, and obviously it's a logical 0. A logical 0 equals false. I can show you that by doing string of answers, and it's false. But they are not equal to. So if you do the not equal to symbol, then it should turn out to be true. And in MATLAB, the not equal to is done using a tilde. So that's a true. Now A is 3 and B is 4. So A is strictly less than B. So if I do A greater than or equal to B, it should turn out to be false, and it is false. And if greater than or equal to is false, then this is also going to be false. Now A is 3 and B is 4, and A is less than B. So less than or equal to B should be true, and it is true. And A less than B should also be true, it is true. So this is all there are to relational operators. The next thing you need to know is logical operators. That is, several times you might be in a situation where you want to check if a certain statement is true, and if another statement is true, then do this. Otherwise, do not do this. I don't think using command line is a good way of showing this. So what I will instead do is I'll show it to you in the live script. So for now, we'll assume that A is some complicated operation for which the result is true. That is, when evaluated, let us say A is some expression like A equal to 3. Okay, so this will always evaluate to 1 because we've set the variable A equal to 3. So I'm assuming that A is some sophisticated equation which leads to a true value, and B is some sophisticated equation that leads to a false value. And this is how you write your if loops. I mean, this is just an example. It will vary on the situation. Now I'm just saying, let me run this. I'm saying A is true, B is false. If B, display B is true. Now the MATLAB interpreter will come here and it will evaluate B, and B is false. So it will ignore this statement, and then it will come to else if, and see else. So if this is false, come here and check this is basically what we're saying. And else if A, that means if A is true, then do something. So by the time you're here, based on this construction, what it means is that if B is false and if A is true, then print A is equal to true, which is exactly what's happening here. B is false, A is true, so you will print this and you will get A is equal to true as the output. Now the else statement kicks in when neither of them are true. So for instance, if I were to change this value from true to false and run this piece of code, you would get neither is true. That's all there is to it. There are also switch case statements.
I think you can leave switch case.
Yes. So I've put in a link for you. So just make sure that you refer to that link if you want switch case. I will go on to loops and I'll take questions on both these sections together. So the next thing you need to know are for loops and while loops. Again, I will only explain for loops here. While loops, I've put in a link for you and you can check the syntax. So a for loop is basically how do you repeat an action or execute a piece of code multiple times. And you get to specify how many times you want to do this. There are more sophisticated ways of writing for loops, but we will stick to the simplest version for now. And as you gain experience, you can write more sophisticated for loops. So just note that all if loops and for loops, etc., unlike in Python or C, need to have an end statement. So if you start with a for, you need to have an end. If you have an if, you need to have an end. So you can run a for, so you will have an iteration variable such as I, or you can name it whatever you want. And you will say run in this range. We've already discussed the colon operator before. So in this range, you run and you do a number of operations several times. I told you that I would show you how to generate multiple bits. And this is exactly it. We're saying for I is equal to 1 is to num bits. That is a million times. Repeat this operation over and over and over and over again. And then we plot the histogram and so on and so forth. Again, this is something purely syntactical. There's nothing brilliant for me to explain here. So you can just refer this link that I've put in for you. And you should be good. Do we have any questions on this?
Yes, am I audible there?
Yes, I can hear you.
Suppose we generate a sequence of bits, and then I have to classify it into some QAM or 16 QAM symbols.
Yes,
so,
okay.
Suppose there are 10,000 bits. Out of these, every symbol will constitute 4 bits, right? So
yes.
How to constitute that? Means how to separate out of the given range of bits, how to classify them into symbols?
Right, okay. So there are two ways of doing this. One, you can write your own.
Milind, I think you should open up a editor and type and do this example.
Sir, I actually have I put this in the future reading section. If I do this here, it might take a bit too much time.
Okay, just at least there's 2-3 things you type it out. It's okay. We can take another 5-10 minutes. It's okay. I mean the IIT.
Right.
Maybe using reshape we can do that.
Sorry.
Reshape function, I think.
No, actually, the simplest way to do this is there's a function called QAMMod. So there's a function called QAMMod in MATLAB, and you can just use it. Sorry. That's strange.
The screen is not visible, sir.
Oh,
it's coming for us.
Is that so? Just give. Right. So as an answer to your question, how will I classify a sequence of bits into constellation symbols? I would say just use this function for now. This is the simplest way of going about it. So if you look at the definition here, QAM mod XM modulates a signal X by using QAM with a specific modulation order M. So if you give it a sequence of, so once you generate your 10,000 bits or so, that would be your X. And if you then feed it to your, if you feed it your constellation value, that is whether it's 4 QAM or 16 QAM or 64 QAM or 256 QAM, it will modulate that and give it to you. If you want, I can give you an example. So there are several ways you can configure this, but let's just do a simple example for now. A is equal to rand of, let me increase the size for you. Rand of 0.1, 10,000.
Mr. Milan, is it necessary to convert bits to digits?
I mean, yes, it is. Okay, let's see. Oh, sorry. So size of A is is 10,000, 1. Now you want to convert this to your QAM modulation. So let's do, and hope this works out okay. Let's say 16 QAM, so you need 4 bits. So you will have 2,500 symbols at the end of the day. And size of B. Okay, what did I do? Okay, these have been modulated. Let's just see here. Right.
I think you should type input type bits. Otherwise, it's taking them as symbols. It's taking them as indices. You should type input type bits. Milind.
I think again he has got this.
So essentially, sir, what you should type is you see the last two. Now you should type those two things also: input type, comma bit. Okay. So when you do that, automatically it will take them as bits. It will group them into four things and map them to constellation points and give you out. If you want to write your own constellation, the way to do is you generate 4 bits in a loop, for example 16 QAM, and then map them into and then use that to map.
Excuse me, sir.
Please.
Sir, in the MathWorks documentation, for example, if it is 16 QAM, it is converted to the symbols of like 11001, for example. So then it is we mandatorily need to convert that into digits, sir. Whatever 1101, for example, it is converted to digits. Then only.
So what they do is, see, essentially there are some indices. See, one thing is, when you have a constellation map, you can think of them as bits or you can think of them as integers, na?
Yeah, okay.
Bits, yeah. So you can think of them integers. So QAM mod takes 2 inputs, I think, so if I'm not mistaken. One is it can take either the integers or it can take bits.
Okay.
It's up to us. It's up to, that's why there's a specific type called input type.
Okay, got it. Yes.
Just wait a minute and otherwise we'll conclude it. Sir, from next class onwards, I'll again resume our OFDM thing. Milind, are you still there? I think he just dropped out. Okay. So I'll continue the OFDM thing. I think this is a decent introduction on MATLAB. And once you start writing up, we'll help you out in the first assignment and a couple of assignments we can help you out. Please, can you let me in?
Sorry for that. There was another power cut. So can you hear me? Hello.
Milind, we can hear you. We can conclude it now.
Okay, sure. I'll just wrap this up fairly quickly. So like I was just showing you, for the QAM mod, you need to specify a few things. You need to specify input type as bit in order for the size to be 2500. And if you do this, it should be fine. I hope that answers your question. You just need to look at the QAM mod documentation carefully and figure out what you need to do. That's all there is to it. So there are just a couple of things left. One is plotting and one is functions. So for plotting, you have several inbuilt MATLAB functions that you can use, such as plot, semilog_y, and semilog_x. Here I've given you a demonstration of semilog_y. What semilog_y does is it takes the y-axis on the logarithmic scale. I don't know if you can see this plot. Let me. No, I can't. I just hope you can.
Hello. Pankaj, can you hear me?
Yes, sir.
Okay. So what is your question? Your question is how to check on which decision boundaries QAM mod function is working. Okay.
Yes, sir.
QAM demod, you mean?
Yes, sir. Demod.
QAM demod. So I think there are in MATLAB there is if you look at the documentation, they tell you how to plot the decision boundaries. Okay.
Okay.
Okay. So I will send you. I'll put that command on Google Classroom. You can check that out.
Okay, sir.
Okay, I think we'll stop this at this point. I think there's a lot of problem on Milind's computer side. We'll just stop it, and whatever is remaining, I'll put it on Google Classroom. And I think there's enough stuff now that you can do the assignment. That should not be an issue. Okay, Milind, we're going to stop it right now. Okay, already people left.
Yeah, sure, sir. Sure, no issues.
Thanks everyone. Thank you.
Yeah.